Chapter 6 Number Play. Numbers tell us things. Here, what do the numbers in the figure below tell us? If you are looking the numbers, we can see how many children are in front of each one, taller than that person. That is the number representing. For the first person, nobody is in front, so always 0. Second person here, for him, one person taller than him, that means 1. For this person, he is the tallest when we are comparing these three. So 0, nobody taller than him. For this person, 1 and 2 are taller than him. Here also these 2 are taller than him. For him, 2 are there. And for the last person, look at the head. Here we can see this one. He is taller than the last one. So according to him, one person ahead of him taller than this the person. So we can write there 1. Same way down also. What do you think these numbers mean? Could you figure it out? What the numbers convey? So here also the same way we can find out the numbers representing the number of people taller than that person ahead of him. Here the first person supposed to say always 0 because nobody is in front of him. Here the second person is taller than the first one. So according to him, nobody is taller than in front. So 0. For the third person, he is taller than him. So he has to say 1. For the fourth one, for him, 2 are taller than him in front of him. So 2 is coming. For the fifth one also, 2 are there taller than him. For the next one, sixth person, here we can see 1, 2, 3, 4, 5. All are taller than him. For the last one, rest of that all are taller than him. He is the shortest one. So rest of that all 6 are taller than him in front of him also. So he has to put 6 or he has to say 6. The rule is each child calls out the number of children in front of them who are taller than them. In front of them and also taller than them. Write down the number each child should say based on this rule. Here the first one, always first one has to say 0, nobody in front of him. Second person, he is taller than the first one, so nobody is taller than him in front. So he also has to say 0. For him, one person in front taller than him, so he has to say 1. According to him, nobody is taller. He is taller when we are comparing all these 4. So nobody is taller than him in front. So he has to say 0. The next person, we can see, look at the line. We can see 1, 2, 3 are there taller than him. So he has to say 3. And for him also, he is the tallest one. So in front of nobody is taller than him. So he has to say 0. And the last person, look at the headline. Here 1, 2, 3 are taller than him. So he has to say 3. Now figure it out. Arrange the stick figures cut out given at the end of this book. We can see the same type of cutouts are there at the end and cut that each one. And after that we can arrange according to the height of the arrangement in the given sequence. Here first one 0, 1, 1, 2, 4, 1, 5. That way we have to arrange. First always 0 because in front of the first person nobody is there. Then according to that we have to arrange the cutouts. Here the first one, to get the sequence like the same way 0, 1, 1, 2, 4, 1, 5. We have to arrange the cutouts in the order F first. F, C, B, G, A, D, E. Look at here. F, C, B, G, A, D, E. If we are arranging like the same way, we can see the sequence. First one, nobody in front of him, that is 0, taller than him. For him, just one person taller than him, so 1. For him also, this one is taller than, so 1 he can put. For G, he can put 2 because this and here, first and third persons are taller than him. So he has to say 2. For A, he has to say 4. 1, 2, 3, 4. If you are keeping the scale, you can see A is shorter. And for D, for him, only one person taller than him. And for E, 5 are there. 1, 2, 3, 4, 5 are there taller than him. So this is the way you have to arrange the cutouts. Same way you can arrange the cutouts according to each sequence here. Next is all 0. That means the height wise increasing order or shorter to taller. That's the way we have to arrange. Then everyone supposed to say 0. In front of that, nobody is taller. Draw a line in a piece of paper and then arrange in the same level. Bottom supposed to be in that line. Then you can look at the height. A, E, C, G, B, D, F. It's shorter to the tallest one. From the shortest to the tallest one. So each one, when they are looking forward or looking ahead, nobody is taller than him. For him, he is shorter. Each one. In front, the last person can say everyone is shorter than him. So he has to say, each one supposed to say 0, 0. So according to that way, we can rearrange the cutouts to get such that according to the given sequence all. So here we can see the rest of that you can do the same way. Next is 0, 1, 2, 3, 4, 5, 6. For that, the same cutouts you have to rearrange that. First F, D, B, G, C, E, A. To get this sequence 0, 1, 0, 1, 0, 1, 0. E, A, G, C, D, B, F. Next one 0 and rest of that all 1. F, A, E, C, G, B, D. First 3 zeros, then next 4 threes. B, D, F, A, E, C, G. This is the way you have to rearrange the cutouts to get each numbers according to the question. The last one 3 zeros and 4 threes. For that the arrangement B, D, F, then A, E, C, G. B, D, F, A, E, C, G. Here 3 of them are saying 0. Nobody in front of them that is taller. But for him, all these 4 people is having these 3 are taller than them. So each one supposed to say 3 there. Figure it out. Second question, page number 128. For each of the statements given below, think and identify if it is always true, only sometimes true, or never true. Share your reasonings. That means you have to say the reason also for that. First one, if a person says 0, then they are the tallest in the group. If a person says 0, then they are the tallest in the group. That's not always correct. The person standing in front says always 0. And also we can see the tallest person always will say 0 if he is standing there in front. But a shorter person can also say 0 if they are at the front. So, or in a position where no one taller is ahead of them. So that statement sometimes true. So we can say the answer is only sometimes true. That means the tallest at the same time the shortest person can say 0. If, for example, if they stands at the front, shortest one is standing in the first position, he has to say 0. So the statement sometimes true, not always. Second statement, if a person is the tallest, then their number is 0. Always true. The tallest person will say always 0. Wherever he stands, he is the tallest one in that group. So he has to say 0. So always true, that statement. C. The first person's number is 0. That also always true. Shorter or taller person, whoever stands first. In front of him, nobody is there. So, there is no one ahead of the first person. So, their number will always be 0. Next one. If a person is not first or last in the line, not the first position, not the last position, that means if they are standing somewhere in between, then they cannot say 0. That statement sometimes true, only sometimes. A person standing in between can say 0 if there are no taller people ahead of them, in front of him. Even if he is standing in between, in front of him, nobody is taller than him, then he can say 0. So that statement only sometimes true. E1. The person who calls out the largest number is the shortest. That also only sometimes true. If the shortest person is standing at the front, then the second shortest person is supposed to say the largest number. For example, the shortest one at the front and rest of that all taller. And the second shortest person supposed to say the largest number. Slight difference in between. He is the second shortest. The shortest one standing in front. So he is not saying the largest number. For him, according to his height, 4 are there in front of him. So he is supposed to say the largest number in this group. 4 of them are taller than him. He is the second shortest in the group. The shortest one standing in front, so he is saying 0 only. So that statement only sometimes true. Reason is, if the shortest person standing at the front, then the second shortest person could be at the back and might call out the largest number. Here, what is the largest number possible in a group of 8 people? If there are 8 people, the shortest person will see 7 taller people. All 7 are in front of him and the shortest one standing at the back. Then the maximum number he can say, that is 7. Total 8 people, all are in front. The shortest one, if he is standing at the back, then according to him, rest of them all are taller. So he can say 7. 7 people are there in front of him. Picking parity. Here 1, 2, 3, 4, 5, 6, 7 groups of numbers are there. We can see all these numbers are odd numbers. 13, 9, 1, 7, 11, 5, 3. And when we are adding any 5 out of this group, supposed to get 30. Here, can you figure out which 5 cards add to 30? There is no card we can pick it out to make the sum as 30. So we can write here no. Is it possible? Not possible. Why? The sum of 5 odd numbers always odd. Here we can see sum of any 5 odd number. Sum of 5 odd numbers, that will be always odd. 27 is odd number. Here another 5 numbers. That also odd. We are getting the answer as odd number. So we can write, is it possible? Not possible. Reason, sum of 5 odd numbers is always odd, but here 30 is an even number. Here the answer is given as 30, that means an even number, but using these cards, odd number cards, we cannot 5 numbers. We cannot choose 5 numbers to get such a way that to get the sum as 30. So not possible. Here add few even numbers together. What kind of number do you get? When we are adding one even number with odd number, we will get even number. So after that, how many even numbers even if we added, we will get remain that as even number. Here now add a few odd numbers together. What kind of number do you get? We will get odd number or even number. Does it matter how many odd numbers are added? Yes, we can see here even number of odd numbers if we are adding, we will get even. Even number as the answer. Odd number of odd numbers if we are adding, we will get odd number as the answer. For example, even number of odd numbers. All these numbers are odd, but even number. 4 numbers are we are adding. 4 odd numbers adding. So we will get the answer here 16. That means even number is the answer. At the same time, 3 odd numbers if we are adding, we will get the answer sum, that also odd. So odd number of 3, 5, 7, that the way odd number of odd numbers adding, we will get sum as odd. Even number of odd numbers are adding, we will get the sum as even. Here, sum of 2 odd numbers must always be even. We know that the sum of 2 odd numbers, 1 plus 3 is equal to 4, even number. 3 plus 5. When we are adding 2 odd numbers, we will get even number, 8. Here, what about adding 3 odd numbers? When we are adding 3 odd numbers, we will get the answer as odd. Explore what happens to the sum of 4 odd numbers. 4 means even number. 4 odd numbers, when we are adding, we will get the answer as even number. 5 odd numbers, 5 is odd number, so 5 odd numbers when we are adding, we will get the answer odd number. 6 is even number, so 6 odd numbers sum, that will be even number. For example, sum of 4 odd numbers. 1, 3, 5, 7, all 4 odd numbers. Addition, sum we are getting 16, that is an even number because 4, even number of odd numbers. Here 5 is an odd number. 5 odd numbers when we are adding, we will get the answer odd. 6 is an even number. So 6 odd numbers when we are adding, we will get answer is even. Here 2 siblings, Martin and Maria, were born exactly 1 year apart. Today they are celebrating their birthday. Maria exclaims that the sum of their age is 112. Is this possible? We can say no, because they are next 2 years, exactly 1 year apart. So one number will be even, the other number, next number will be odd. Or the first number is odd, next number will be even. Whatever it is, one even number and the other is odd number. When we are adding one even number and odd number, always the answer will be odd number. But here she is getting 112, so that is not possible. Sum that will be an odd number. The resulting sum of an even number and an odd number will be always an odd number. Therefore, 112 is an even number, which means Maria's and Martin's ages are consecutive numbers. They cannot add up to 112. Here we are using the term parity to denote the property of being even or odd. Even or odd, that property. To mention that, the term using parity. For example, here the parity of the sum of any 2 consecutive numbers is always odd. Continuous number always, that will be odd. Parity of the sum of any 2 odd numbers. When we are adding 2 odd numbers, always the result will be even. Now figure it out. Page number 131. Now, first question, using your understanding of the pictorial representation of odd and even numbers, find out the parity of the following sums. Sum of two even numbers and two odd numbers. Two even numbers means even plus even, and two odd numbers means odd plus odd. So we can write it here, even plus odd plus odd. Even plus even always we will get an even number. Same way odd plus odd also will get even number. Then even plus even always even. When we are adding two even numbers, always even. Two odd numbers, if we are adding, for example, 1 plus 3, two odd numbers, 4. 3 plus 5, two odd numbers, 8. So two odd numbers, sum will be even. Two even numbers, sum that also will be even. So parity of the result is even. Example is here given. Two even numbers, 2, 4. Two odd numbers, 1, 3. 2 plus 4, 6. 1 plus 3, 4. Sum is 10, that means even number. Now next one. Sum of two odd numbers and three even numbers. Two odd numbers and three even numbers. So two odd numbers, when we are adding, we will get even number. Even numbers, when we are adding 1 or 2 or 3, whatever, we will get even only. So even plus even, again even. So parity of the result is even. Two odd numbers, 3 and 5. Three even numbers. 3 plus 5, 8. When we are adding two odd numbers, we will get even. 2 plus 4 plus 6, that also even. So the answer is even. C1, sum of 5 even numbers. Adding 5 even numbers always give an even number. Parity of the result is even. Any 5 even numbers, we will get the answer even number only. Sum of 8 odd numbers, that means even number of odd numbers sum. That also will be even. Sum of 8 odd numbers. We know that two odd numbers, odd pairs. Odd plus odd will get even. So 8 odd numbers means 4 such type of pairs. 4 odd pairs. 4 odd pairs. So one pair is even. So like that way 4 pairs. So it's equal to even. So parity of the result is even. Example is here, 8 odd numbers, 1, 3, 5, 7, 9, 11, 13, 15. 8 odd numbers. Sum is even, 64. Second question. Lakpa has an odd number of 1 rupee coins and odd number of 5 rupee coins and an even number of 10 rupee coins in his piggy bank. He calculated the total and he got 205 rupees. Did he make a mistake? If he did, explain why. If he didn't, how many coins in each type could he have? So here we can see odd number of 1 rupee coins, odd number of 5 rupee coins. 1 and 5 are odd. So odd number plus odd number we will get, that is even. Then even number of 10 coins. So that also even. Even plus even number only we will get. But here the total is 205, which means he made mistake. We can write that in this way. Odd number of rupee 1 plus odd number of rupee 5. So two odd numbers that will come even. And then adding even number of rupee 10. So even plus even, again even supposed to get. But here 205 is an odd number, which is not possible. We are supposed to get the total as even number only. Which means Lakba, he made a mistake in that. Third question, we know that even plus even number, odd plus odd also even. One is even and the other one is odd, then the result will be odd. Similarly, find out the parity for the scenarios below. Even minus even, that will be even. We can consider any number, even number. 8 minus 2 is equal to 6. That means even number. Odd minus odd. 7 minus 5 is equal to 2. That also even. Even minus odd. Even is 8 minus odd 5. 8 minus 5, 3. So we are getting odd number. Odd minus even. 7 minus 4. 3. Odd number. So through examples we can write it here. Even minus even. Odd minus odd even. One is odd or the other one is even. Then the result will be, in the case of subtraction, also odd. Here next is product. Find small squares without calculating the product. Given the dimensions of the grid, can you tell the parity of the number of small squares without calculating the product? Product of two numbers, that we can say. So you can write yes, product of two numbers. First case, that will be even if at least one number is even. For example, one number is even. If you are taking 2 as the even number, 2 into 3. 3 is an odd number. 2 into 3, 6. 2 into 4, 8. So odd number or even number, if at least one number is even, when you are multiplying, we will get the result is even. Then odd, if both numbers are odd. 3 into 3, 9. 3 into 5, 15. So everywhere we are getting odd numbers. The answer is odd number. That means both the numbers are odd, then the product also will be odd. At least one number is even, then the result will be even. So we can write even if, answer product will be even if at least one number is even. Product will be odd if both the numbers are odd. Here, find the parity of the number of small squares in these grids. 27 into 13. 27 is an odd number. 13 is also odd number. So we know that odd into odd, well, the result will be odd number. So we can write parity of the number of small squares is odd in this case. Next, one number, first number is 42, that means even number. 78, that also even number. So even number into even number, result will be even number. Parity of the number of small squares is even. Third one, 135. One number is odd, the other one is even. Odd into even. At least one number is even, then the result will be, product will be even. So there also we can write parity of the number of small squares is even. Here 3n plus 4. Value of n, different values for n we can take. If we are taking an odd number, n is equal to 3, then 3 into 3, 9 plus 4, 13. The result will be odd. If you are taking n is equal to 8, 3 into 8, 24 plus 4, 28, answer is even. If you are taking n is equal to 10, 3 into 10, 30 plus 4, 34, that is an even number. Now again, come up with an expression that always has an even parity. For some example, 100p. 100 is an even number. One number product means one number is even, then the result will be even. So 100p, 48w minus p. You can write any number like that way. 2p plus 10. 6m minus 4. 6m plus 4. 8m minus 2. Now we can write it. Next, come up with expressions that always have odd parity. Odd parity means the even plus 1. 2m is an even number, that plus 1 or minus 1. 2m plus 1 or 2m minus 1. Same way, 6p plus 3, 6p minus 3, 6p plus 5. When we are adding or subtracting an odd number, with that we will get odd number always. Next, come up with other expressions like 3n plus 4, which could have either odd or even parity. 3n plus 4, this is an even parity. Here 5p minus 2, m plus 5, 3w minus 2. So we can write any expression like the same way. have either odd or even parity, whatever, even number or odd number. Next is the expression 6k plus 2. Evaluate 8, 14, 20 for k is equal to 1, 2, 3. When we are giving the value for k as 1, 6 into 1, 6 plus 2, 8 we will get. If k is equal to 2, 6 into 2, 12 plus 2, 14. When k is equal to 3, 18 plus 2, 20. Then how many even numbers are missing there? Here we can see 8, 14, 20, etc. is going on. Here before that 2, 4, 6 are missing. Then after 8, 10, 12 are missing. Then after 14 to 20, 16, 18 are missing, etc. So like this way all even numbers are not there. In between some are missing. Are there the expressions using which we can list all even numbers? Yes. We can use the expression 2n. When n is equal to 1, 2, 3. So we will get the answer. When n is equal to 1, we will get the first number 2. Even number 2. When n is equal to 2, 4. N is equal to 3, 2 into 3, 6. N is equal to 4, 2 into 4, 8, etc. So 2, 4, 6, 8. All even numbers will come over there. So the expression is 2n to represent all even numbers. Are there the expressions using which we can list all odd numbers? That also yes, possible. Here 2n representing the even numbers, 2n minus 1 representing all odd numbers. When n is equal to 1, 2 into 1, 2 minus 1, 1. When n is equal to 2, 2 into 2, 4, 4 minus 1, 3. When n is equal to 3, 2 into 3, 6, 6 minus 1, 5. So all odd numbers are coming there. So the expression to represent all odd numbers, that is all odd numbers, that is 2n minus 1. All the even numbers, that the expression 2n. Now here what would be the nth term for the multiples of 2? Nth term means 2 into n, that means 2n. And what is the nth even number? Even number, nth, that also nth term. Even number means 2 into that number, 2n. Then what is the 100th odd number? We know that 100th even number, that is 2n, that means 2 into 100, 200. 100th odd number. Here even numbers starting from 2, 4, 6, etc. Odd numbers 1, 3, 5, etc. So the 100th odd even number is 200. 100th odd number, that means just minus 1. 200 minus 1, 199. 100th odd number is 199. 100th even number is 200, 2n. Here 2n minus 1. That is coming here. 2n is the 100th number, nth number, and odd number is 2n minus 1. 2n is the formula that gives nth even number, and 2n minus 1 is the formula that gives nth odd number. Now here the grid. Use the numbers 1 to 9 without repeating any of them. And there are the circled numbers outside the grid. To get the sum as that. The yellow circles are the sums corresponding to the rows and columns. Here we can see when we are adding row wise, 4 plus 7 plus 5 is equal to 16. 6 plus 1 plus 2 is equal to 9. 3 plus 9 plus 8 is equal to 20. Then column, first column, 4 plus 6, 10 plus 3, 13. 7 plus 1, 8 plus 9, 17. 5 plus 2 plus 8 is equal to 15. Such a way that we have to fill the here. 9 plus 2 numbers here is equal to 13. So we can put here 1, 3. 9 plus 1, 10. 10 plus 3, 13 will come. Then this column, 24 supposed to get, 9 is already there. So corresponding that if you are putting 8, 7. So 9 plus 8 plus 7, that is equal to 24. Then these two squares, 8 plus 2 numbers, which is equal to 14. So 8 plus 2, 10. 10 plus 4, 14. Again we have to check column also. Column wise, 3 plus 4, 7. 7 plus 5, 12. Here 1 plus 2, 3. Then 9 supposed to get. That means here 6. And check column wise. 7 plus 6 plus 5, 18. So row wise and column wise. By trial method, we can find the numbers, missing numbers. Here in this one, 4 is here. We have to get 15. So if you are putting 6 and 5, 15 it will come. Now already in this column, 5 and 3 is there already, and we have to get the sum as 17. 5 plus 3, 8. 8 plus what is equal to 17? 9. So we can put here 9. Now this row we can consider. 24 supposed to get. 9 is already there. So 7 and 8. 24. Now for this column, 7 and 4 are there. 12 supposed to get. So 7 plus 4 already 11. Then 1 only missing. Then this column, this row, 1 and 3 there. 6 supposed to get. So 3 plus 1, 4. 4 plus 2. 6. Then check once more. All the rows and columns is the same or not the sum. Now here, try to solving this problem below. Here we can see 5, 21, 19, 9, 11, 26 are the row and column sums. But we know that the numbers we are using from 1 to 9. The small and without repeating the numbers. So the smallest numbers, if you are taking 1 plus 2 plus 3 is equal to 6. 6 supposed to be the smallest sum of the row or column. But here 5 is given. 3 numbers when we are adding to get 5 is not possible. Same way, the biggest number up to 9 we are taking the digits. So 9 plus 8 plus 7, that's supposed to be 20, that is equal to 24. But here 26 is there. So by adding these 3 numbers, maximum number supposed to get 24. But here it is given 26. That also not possible. So we can write here clearly any number in the circle cannot be less than 6. 5 is here or greater than 24. 26 is here. So the grid has sums 5 and 26. Therefore this is impossible. Not possible to complete the grid like this way. Now here magic sum. The square grid of numbers is called magic square, and also if each row and each column and each diagonal, if we are getting add up to the same number, each row, each column and each diagonal add up to the same number, then that number is called magic sum. This column 1, column 3 columns, here 3 rows and the diagonal like this way. 1, 2, 3, here 1, 2, 3 like this way. When we are adding, everywhere if we are getting the same number, then that number is called magic sum. By trial method, when we are looking, we can see some rules that getting observations here. Such that 1 and 9 cannot occur in any corner, so they should occur in one of the middle positions. So 1 and 9 is arranging like this way. Through different way we can make the magic square. Now we have one full row or column of the magic square, then trying to complete the same way. First fill the row and columns containing 1 and 9. So then some hints. Now figure it out. How many different magic squares can be made using the numbers 1 to 9? Here only 1, but we can arrange that in different ways. 8 different ways. first row we can make it, change that as column. Different way we can make it in 8 different ways. Second question, create a magic square using the numbers 2 to 10. What strategy would you use for this? Compare it with the magic squares made 1 to 9. First we can make the magic square 1 to 9 using the numbers from 1 to 9. 8, 1, 6, 3, 5, 7, 4, 9, 2. Everywhere we are getting the sum as 15. So magic sum is 15. If you are adding row wise, 8 plus 1 plus 6, it's equal to 15. This row 15, this one 15. Then column also we will get everywhere 15. And also diagonal. 5 plus 4, 9. This is the diagonal. 5 plus 4, 9. 9 plus 6, 15. This is the second diagonal. 8 plus 2, 10. 10 plus 5, 15. So magic sum is 15. And to make the numbers 2 to 10, just add 1 with each number. 8 plus 1, 9. 1 plus 1, 2. 6 plus 1, 7. In place of 3, 5, 7, here 4, 6, 8. Just add 1. 4 plus 1, 5. 9 plus 1, 10. 2 plus 1, 3. So starting from 2 and ending with the 10. Here the magic sum is coming 18. When the number starting from 2 to 10, magic sum is 18. If you are adding, we can see this side is 18 everywhere. And column also. Then diagonal. Check the diagonal. 5 plus 6, 11 plus 7, 18. This diagonal. 9 plus 6, 15 plus 3, 18. So everywhere row, column and diagonal. All three things we are getting the same number, then we can say that is the magic sum. So how we frame this second square, magic square? After adding 1 to each number, we get the magic square of numbers 2 to 10 with magic sum 18. Third question, take a magic square and first one, increase each number by 1. That already we did here. Double each number. In each case, is the resulting grid also a magic square? Yes. How do the magic sums change in each case? You can see through the example here. First, the original grid. Everywhere the sum is 15. Magic sum 15. And for that 15 we are getting the center number is 5. 3 into center number we are getting 50. First one, A. After increasing each number by 1. When we are adding 1 with each number in this grid, we will get the new one. 9, 2, 7, 4, 6, 8, 5, 10, 3. Same as the second question what we did just now. And here the magic sum. Row, column and diagonal. Everywhere we are getting 18. So we can write the magic sum is 18. But here the middle number is 6. There also 6 in 3 into that center number. is equal to 18. Now B section, double each number. Original one is 8. When we are double that number, multiply by 2 or 8 plus 8, 16. Double of 1, that is 2. 6 plus 6, 12. 3 plus 3, 6. 5 plus 5, 10. 7 plus 7, 14. Then 8, 18, 4. Here everywhere we can see row, column and diagonal. Everything we are getting the sum as 30. So we can write the magic sum is 30. How we are getting the center number is 10. So there also 30 means 3 into the center number. 3 into 10, 30. So this by adding 1, here by doubling the number. So both the cases here. Increase each number by 1 and here. How do the magic sum change in each case? So we can see by when we are doubling the number, the magic sum is here 15, here 18, here 30 is coming. Fourth question, what other operations can be performed on magic square to yield another magic square? By adding 1, we got 1. By double the number, we got another magic square. Then you can try to find out different way. Here by multiplying with any number 4. Multiply the original 1 by 4. Each and every digit. So here we will get 32, 4, 24, 12, 20, 28. 16, 36, 8, and when we are adding everywhere we will get that the sum is 60 diagonally and also column wise everywhere, row wise everywhere 60. So we can write the magic sum is 60. So the same way you can try and find out different magic squares. Fifth question. Discuss the ways of creating a magic square using any set of 9 consecutive numbers. Consecutive numbers means continuous numbers. The original one from 1 to 9 we use the digits. Here 2 to 10 or starting with 3 then one more number here after 10, 11. Starting with 9 it will come 17. So continuous 9 numbers we need. And how to frame that each one. So we can do like the same way. If you are taking 4 to 10, 2 to 10, then add 1 to each number in the original. We get the magic square with the magic sum 18. So the number it is coming 2 to 10 and the magic sum is 18. For 3 to 11, 1 and 2 we have to remove. That means add 2 to each number with the original one. So we will get here 10, 3, 8, 5, 7, 9, 6, 11, 4, etc. And is equal to 21 as the magic sum. For 9 to 11, add 8 to each number in the original. Then we get the magic square with the magic sum 39. Here in each case we are adding the number with the original. Here add 1 with the original. Original means this is the original square 8, 1, 6. Adding 1 with 8 it will become here 9. Here 1 plus 1 2. 6 plus 1 7. Like that way each square or grid we have to add 1 to get this one. For the next one add 2 to the original one. 8 plus 2, 10, 1 plus 2, 3. So it is coming 10, 3 like that way. For the next one, add 8 with the original one. 8 plus 8, 16, 1 plus 8, 9. So 16, 9, etc. And the magic square. Magic sum is 39. Now in generalized form, we can see if the sender is m, sender number is m, then right side m plus 2, left side m minus 2. Top m minus 4, down m plus 4. Corner m plus 3, m minus 3, m plus 1, m minus 1. This is the original one. So we can make by using the generalized form. Any number as the sender and using that the rest of the grid we can fill it. Now here the first question, figure it out, page number 137. Using this generalized form, find a magic square if the sender number is 25. Sender number is given that as 25. So we have to put that in place of m, that is 25. And left side m minus 2, here m plus 2. Using that we can fill here. We can see sender number 25, 25 minus 2, 25 plus 2. 25 minus 4, 25 plus 4. In place of m, 25. 25 plus 3, 25 minus 3. 25 plus 1, 25 minus 1. And after that we are getting the number. 25 plus 3 means 28. 25 minus 4, 21. 26. All these numbers we will get. And when we are adding everywhere, we can see 75 is coming. Column, row and diagonal everywhere. So we can see the center number is 25 and magic sum that is 75. Central number is 25. Magic sum, that is 75. So magic sum is equal to 3 into central number, which is equal to 3 into 25 is equal to 75. The second question, what is the expression obtained by adding 3 terms of any row, column or diagonal? In the generalized form here, if we can see that if we are adding this column m minus 4 plus m plus 4, we will get 3m. So everywhere we can see that is m plus 1 plus 2, 3, and this minus 3, it will cancel 3m. Diagonal also like the same way. So everywhere we will get, when we are adding 3 terms of any row, column or diagonal, we will get that is the 3m. m is the center number. In this case, here we are considering 25 as the center, then the center number it will come 3m. m is equal to 25. So 3 into 25 is equal to 75. That is the magic sum here. 3 terms of any row, column, diagonal we are getting in this question 75. In general, that will be 3m. m is the central number. Now third question. Write the result obtained by adding 1 to every term in the generalized form. Generalized form, this one. Add 1 to every term. So the center number it will come m plus 1. Like that way it will change everywhere. And B, doubling every term in the generalized form. Make it double 2 times. So we can write in this form. This is the general form. And adding 1 to every number, m minus 4 plus 1, that will come m minus 3, m plus 3 plus 1, it will come m plus 4, and m it will come m plus 1, here m plus 3. This is the by adding one term. So by adding 1 to each number, each term. B part, double each and every term. First it is m plus 3. So I can see that m plus 3 plus m plus 3. Double means 2 times. So it will come 2m plus 6. That is the first number. Then m plus m, 2m at the center. m minus 4 2 times. m minus 4 plus m minus 4. It will come 2m minus 8 here. So each term make it 2 times. Double that. We will get the this grid. For the first part, adding 1 to each number, each term. Here doubling every term. Question number 4. Create a magic square whose magic sum is 60. Magic sum is 60, which means the center number is supposed to be 60 by 3, 20. We know that 3 into center number is equal to magic sum. Magic sum always 3 into center number. It's equal to magic sum. Here magic sum is 60. So 60 by 3, 20. 20 is the center number. So first you have to write 20 here. And take the original one. Check that. To get 20, 5 into what? 5 into 4 is equal to 20. So multiply each and every term by 4. 8 into 4, 32. 1 into 4, 4. 6 into 4, 24. Like that way every term. After that, when we are adding the row wise, we can see everywhere we are getting 60. Row wise, column wise, and diagonal also. Diagonal means these 3. There are also 60. So magic sum is 60. The original one is 15. So original one, when we are, so the center number first you have to put in the square and then check by the with the original one. 5 into what is equal to that number? 5 into 4 is equal to 20. So multiply each and every number with 4. You will get the required magic square. Fifth question, is it possible to get a magic square by filling 9 non-consecutive, that means not continuous numbers? Yes, it is possible. Magic square with a magic sum 45 in both the case. Here we are taking 9 consecutive numbers from 11 till 9, 11, 12, 13, 14, 15, 18 up to 19. 9 consecutive numbers, magic sum is 45. Here we are taking not non-consecutive numbers, 9 non-consecutive numbers, and there also the magic sum is 45. So according to the question, that is possible. The question is it possible to get a magic square? So we got the magic square with the non-consecutive numbers also. Now first ever 4x4 magic square. It's called Chautiya Yantra, which means 34. Every row and column and diagonal in this magic square adds up to 34. Here, can you find other patterns of 4 numbers in the square that add up to 34? Such a way that we can find 4 numbers. So we can write yes. For example, here we can see we can find different combinations of 4 numbers that add up to 34 in the given square. Sum of 4 corner numbers are 7, 14, 4, 9. We will get 34. Central numbers 13, 8, 10, 3, 34. Sum of 4 numbers in any square. Top left square. We can see that is 34. So different patterns. That means if we are taking this square 7 plus 12 plus 2 plus 13. If we are adding these 4, we are getting 34. Same way every square we can see that pattern. Other patterns of 4 numbers. So we will get different patterns. We are taking the center number, this one, 13 plus 8 plus 10 plus 3, that is here, 34. For corner number, 7 plus 14 plus 4 plus 9, that also 34. So every square we will get that as 34. So different patterns we can see in this square itself. Here we can see different all the ways writing each of the numbers 1, 2, 3, 4 as the sum of 1s and 2s. Different ways and number of ways. N is equal to 1, that means 1 only. 2, we can write 1 plus 1 and straight 2 itself. 3, that we can write 1 plus 1 plus 1 or 1 plus 2 or 2 plus 1. So 3 different way. If n is equal to 4, here we can see 1 plus 1 plus 1 plus 1. One method, 1 plus 1 plus 2, 1 plus 2 plus 1, 2 plus 1 plus 1, 2 plus 2. So 5 different way we can write it using 1 and 2 only. Same way here for the number 5. We can write in different way using 1 and 2 only. Then next, the rhythm. There are 8 rhythms having 5 beats. And here the question, write 6 as the sum of 1 and 2s in all possible ways. Did you get 13 ways? We can check that. Write 6 as the sum of 1 and 2s. We can use only 1 and 2, the digits, and all different methods we have to write. Total 13 ways we will get or not. Here we get all 13 ways. So n is equal to 6. First or with 1 only. Then 1, 2 we have to place in different places. Last, then second last, third last, like that way till here. Then with 2 2s. Here, different places. Then finally with the 3 2s. So all together when we are counting 2, 4, 6, 8, 10, 12, 13. So 13 ways. We will get 13 ways. So we can write yes. We are getting 13 ways that. Here in page number 142. Write the next 3 numbers in the sequence. 1, 2, 3, 5, etc. This is called Virahanga sequence. We can see when we are adding two numbers, 1 plus 2, next number will get 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. So 21 plus 34, 55. 34 plus 55, 89. 55 plus 89. The next number is 55 plus 89, 144. The next number 89 plus 144. These two to get 233. Then the next one 144 plus 233. 377. It is going on that. To get the next one 233 plus 377. It's going on like that way. And the pattern we can see odd, even, odd. Odd number, even, odd. Odd, even, odd. Or we can say that as odd, even, odd, odd, even, odd, odd, even, like that way. The pattern is going like that way. Odd, even, odd, even, odd, even, etc. Here, what is the parity of each number in the sequence? So we can see this the pattern it's going on. Do you notice any pattern in the sequence of parities? Here this is called Virahanga Fibonacci, and here the numbers we can see in our day-to-day life, in our outside garden or anywhere, architecture or visual arts or poetry to drumming, artist theories, everywhere they are using this number pattern. For example, the number of petals on a daisy is generally Virahanga number. How many petals can see here? 13. And here in this daisy 21 petals. Here 34 petals. You can see these numbers are coming there, the number of petals. So for here we can write the answer like the same way, odd, even. That means two odd numbers are followed by one even number. So the pattern of parities, repeat every three terms as odd, even. So the numbers we can complete like the same way. The next number after 377, that will be even, because this odd, next will be even, as per the repeating parity cycle. In the calculation below, the digits are replaced by letters. Each letter stands for a particular digit 0 to 9. The digits we are using. You have to figure out which digit each letter stands for. Here we can see T 3 times when we are adding. Here again it is coming T. So we have to check with each digit 1, 2, 3, each digit 3 times when we are adding. We can see that if T is equal to 5, 5 plus 5, 10, again 5, 15. That means 5 is coming in place of T. 15 and in this place 1. So when we are adding 5 3 times, we will get 15, which means in place of T, 5 and U is equal to 1. So we can write here T is equal to 5 and UT. That means the answer is 15. Same way we can find out for by trial method. Here K2 plus K2. K2 is the number. So 2 plus 2, that will be 4, which means M is equal to 4. And K plus K supposed to get here 4 and here another digit. So this M is 4, 2 plus 2, 4, this also 4, and here supposed to come another digit, which means if here K is equal to 7, 7 plus 7, 14. Here 14 supposed to, that means is coming, which means H is equal to 1 and M is equal to 4, K is equal to 7. So we can write that number as in place of K2, 72 plus 72 is equal to 144. Here, what about H? Can it be 2? Can it be 3? No, because the highest number, if we are giving for k, highest digit is 9. 9 plus 9 is equal to 18. So in this place, hundreds place, only 1 it will come. But here we have to get the same digit, m. So here 4, which means this also 4, which implies 7 plus 7, 14. Here are some more numbers the same way. To find out y plus z is equal to z Before that, the same thing here. 72 plus 72, 144, m is equal to 4, k is equal to 7, h is equal to 1, h cannot be 2 or 3. Now in this question, z plus z is equal to z0 So here we can see y is a 2-digit number. 2-digit number means same digit is repeating. 77, 88, 99, etc. And when we are adding, here only 1 digit. And supposed to, here it's getting 0. So 2-digit number 99 plus 1. 9 plus 1, 0. And again that plus 1, 0. So 1, 0, 0. Which means y is equal to 9, z is equal to 1, and o is equal to 0. Second one, b5 plus 3d is equal to ed5. Here 5 plus dash is equal to 5. We are using the digits from 0 to 9. The highest digit 9 plus 5 is 14. It will not get 5. So the another option is here d is equal to 0. If d is equal to 0, then 5 plus 0 is equal to 5. Which means d is equal to 0. So here in this place also d is equal to, we can put 0. Now we got this digit as 5. 5 plus 0 is equal to 5. And dash plus 3 is equal to 0, which means 7. 7 plus 3, 10. So E is equal to 1, D is equal to 0, B is equal to 7. The numbers 75 plus 30 is equal to 105. D is equal to 0, B is equal to 7, E is equal to 1. Next one here, KP plus KP is equal to PRR. So P plus P is equal to R, which means 2 times Kp is equal to PRR. 2 times Kp is equal to PRR. If we are putting the highest digit 9 here, 2 into 9, it will come 18, which means P is equal to 1. Hundreds place always the digit is P is equal to, here is coming that as 1. Then if P is equal to 1, here P is equal to 1, 1 plus 1, this will become 2. Which means R is equal to 2. So 1 plus 1 is equal to 2. P already we got that as 1. And here also R is 2. So 12, to get 12, K is supposed to be 6. 6 plus 6 only, it will come 12. So we can write the number 61 plus 61, 122. And P is equal to 1, R is equal to 2, K is equal to 6. Next one, C1 plus C is equal to 1FF. C1 plus C is equal to F. So 1 plus C is equal to F. Again, C plus 1 is equal to a 2-digit number. So C is equal to 9. Which means 9 plus 1 is equal to 10. So F is equal to 0. So F is equal to 0. Here also it will come 0. Which means this is 9. So 91 plus 9 is equal to 100. C is equal to 9. F is equal to 0. Figure it out. Page number 143. A light bulb is on. Dorji toggles its switch 77 times. Will the bulb be on or off? Why? At present bulb is on. Then when he is toggle first time, third time, fifth time, like that a odd number of times the bulb will be off. 77 is an odd number. So after 77 toggles, the bulb will be off. So at present it is on. First time he toggles, it will become off. First time it will become off. Then second time toggles, it will become on. Third time it will become off, which means odd number of times it is off. Even number of times that will be on. 77 is an odd number. So after 77 toggles, that bulb will be off. Odd number, so off. Second question. Liswini has a large old encyclopedia. When she opened it, several loose pages fell out of it. She counted 50 sheets in total, each printed on both sides. Can the sum of the pages numbers of the loose sheets be 6000? Why or why not? So here 50 sheets are there. We know that the page number is both the sides are printed. So this side and the other side it is page number. One will be odd number, the other one will be even number. If you are starting with 1, then 1, 2, then 3, 4, like that is going. So one side of the printed page that will be odd number, the other side will be even number. So we can take that as, suppose there are 50 random sheets. Each sheet has an odd number, that means 2n minus 1, and an even number. One side will be odd number, the other side will be even number. So odd number, we know that we can write that as by the expression 2n minus 1, and even number by the expression 2n. So one page together, both the side, it will come. So total of both page numbers on one sheet, both the side, this side and this side together, it will come odd number plus even number. So 2n minus 1 plus 2n, which means 4n minus 1. So one page itself, that sum of the total page numbers of both the sides of one sheet, that is 4n minus 1. Like that way 50 sheets are there. So n we can take as n1 first sheet, n2, n3, like that way up to n50. 15 sheets are there. So sum of all these n50 sheets, 50 sheets are there. So sum of all these 50 sheets we can write as, when n is equal to 1, the first sheet 4n1 minus 1. Second sheet 4n2 minus 1. Third sheet 4n3 minus 1, like that way 4n50 minus 1. So we can take from the first term 4 outside. So what is remaining? n1 plus n2 plus n3 plus up to n50 minus 1 plus minus sign we can take as common. Then 1 plus 1 plus 1 plus up to 50 times it will come. Which means this 1 plus 1 plus, that is 50 minus sign, so minus 50. Here we are getting 4 into this 4n1 plus 4n2 plus 4n3 etc. for n50. From here all these terms, that means we are opening this bracket. To find the sum of both sides of 50 sheets, open this bracket, it will come 4n1 plus 4n2 plus 4n3 plus 4 etc. for n50, that minus all these ones. Every bracket contains 1. So minus sign we can take as common. So 50. From these terms we can take 4 as common. Inside the bracket n1 plus n2 plus up to n50, and sum of all this 150 times, that means 50. Minus sign applying, so minus 50. Now we know that the first term 4 into sum of n terms, which is divisible by 4. 4, it's a product of 4. So we can divide by 4. But 50 is not divisible by 4. 50 we cannot divide by 4. 48 it will go, and by 50 divided by 4, 2 will be the remainder. Which means this number is divisible by 4. The second number 50 is not divisible by 4. Which means the sum is not divisible by 4. From that 50, when we are minusing, sum of 50 page numbers will not be divisible by 4. But here it is given 6,000. 6,000 we know that is divisible by 4. We can completely divide by 4. But here when we are doing the calculation work, here we are getting that number is not divisible by 4. Not divisible by 4. So in conclusion we can write the sum of the page numbers of the loose sheets can never be 6,000. It cannot become 6,000. That answer 6,000 is wrong. Now third question. Here is a 2 into 3 grid. For each row and column, the parity of the sum is written in the circle E for even number, O for odd. Fill the 6 boxes with 3 odd numbers and 3 even numbers to satisfy the parity of the row and column sums. We can write any number here such that here to get odd number as the sum. If we are taking 4, 3, 2, one odd number and 2 even numbers, sum will be odd. Here even answer we got to get, which means 2 even number or 2 odd number. Here we need 3 even numbers and 3 odd numbers. So only one odd number is come here. Now 2 more we need. 6, 5, 7. So 6 plus 5 plus 7 is an even number. Here 2 plus 7, 9, that is odd. 3 plus 5, 2 odd numbers sum, that is even. 4 plus 6 even plus even, that also even number. So you can write any number such that to get odd or even as the sum. Here is another example for that question. To get odd means one of the numbers supposed to be odd. Even plus even plus odd, that is odd. To get even, 2 odds and 1 even. Odd plus odd even plus even, that will be even. Odd plus odd even plus even plus odd, odd. So you can write the number anyway. Here another example. 1, 2, 4. That means 3 plus 4, 7 odd. This even. Here even and even, odd. Can write different numbers here in place of such a way that to get the same way the odd and even as the sum. Question number 4. Make a 3 by 3 magic square with 0 as the magic sum. 0 as the magic sum. All numbers cannot be 0. Use negative numbers as needed. So from the generalized form of the magic square, we can just put 0 as the center. Then we will get the remaining terms of the numbers of the square. For example, here the generalized form means the middle m, right side m plus 2, left side m minus 2. Top m minus 4, down m plus 4. Here m plus 1, m minus 1. M minus 3, m plus 3. So put 0 at the center. 0 plus 2, 2, 0 minus 2, minus 2, 0 minus 4, plus 4, 1 minus 1, minus 3, 3. So everywhere if we are looking, we can see the sum is 0. 1 plus 2, 3, 3 minus, plus minus 3, 0. Minus 4 plus 0 plus 4, 0. 3 minus 1, 0. Here also the same way, everywhere we are getting 0. So the magic sum is 0. Fifth one, fill in the blanks here with the odd or even. Sum of an odd number of even numbers. Odd number of even numbers is even number. Odd number or even number. That means even number sum always be even. Even number of odd numbers, that also even. For example, the first one, odd number of even numbers. That means 2 plus 4 plus 6. 3 numbers. 3 numbers means odd. Odd number of even numbers. Sum is 12. Even. Here, even number of odd numbers. 3 plus 5 is equal to 8. Even. Here, even number of odd numbers. Sum of even number of even numbers. That also even. Sum of odd number of odd numbers is odd. 1 plus 3 plus 5. 3 numbers, odd number of odd numbers. Here we are getting 9. So odd number. Now here, what is the parity of the sum of the numbers from 1 to 100? From 1 to 100, we can write that in the form here. 1 plus 2 is equal to 2 and the next number 3 by 2 is equal to 3. That means 2 into 3 is 6, 6 by 2, 3. 1 plus 2, sum is 3. 3 numbers if you are taking. Last number 3 and the next number 4. 3 into 4, 12. That divided by 2, 6. If we are adding 1 plus 2 plus 3, we will get the sum as 6. Again, if you are taking 4 numbers, last number digit is 4. Next number that is 5. 4 into 5, 20. 20 by 2, 10. If you are adding this all, we will get 10. In general, we can write sum of n terms. N can be any number, 2 number, 3, 4, 5 or 100, whatever, which is equal to last number n, that into n plus 1 divided by 2. If you are taking for 100 numbers from 1 till 100, so last number is 100, then the next one 100 into 101 divided by 2, that we will get 5050. So 5050 is an even number, which means parity is even. Question number 7. Two consecutive numbers of Virahanga sequence are 987 and 1597. What are the next two numbers in the sequence and what are the previous two numbers in the sequence? Next two numbers means we have to add and get. Here the given numbers 987 and 1597. The next two numbers. So these two we have to add. 987 plus 1597 is equal to 2584. To get the next number, these two we have to add. 4181. Same way to get the previous number. This number minus the smaller number, previous number. So 610. Again, this number minus 610, we will get 377. So the sequence is coming. Some other numbers are there. Then 377, 610, 9. Then the given number 987, 1597, and then 2584, 4181. Then etc. It is going on. So to get the Virahanga sequence means add two numbers, you will get the next one. Then add the next two numbers, you will get the next one. Like that it is going on. Question number 8. Angan wants to climb an 8-step staircase. 8-step. His playful rule is that he can take either 1 step or 2 steps at a time. For example, one of his parts 1, 2, 2, 1, 2. In how many different ways can he reach the top? That means 8 steps. So n is equal to 8 if we are taking. We can see it's already we have done the previous question. Now different ways to arrange that. N is equal to 8. N is equal to 6 we have done before. 13 ways in the previous page. Now here n is equal to 8. Different ways and number of ways. First one, 1 step everywhere. So that only one arrangement. Then 6 steps 1 and then 1, 2. That we can arrange in different way. 7 different ways. Then we can take 2 steps with 2. 2 plus 2, 4 and remaining 4 with the 1s. So 4 plus 4, total 8. That 2 we can arrange in different way. Keep this 2 here, the other 2 is moving here from this to each position till here. Same way the second 2, like that way when we are arranging we will get 15 different way we can arrange 2 2s and 4 1s here. Then 3 2s and 2 1s. 2 plus 2 4 plus 2 6, 6 plus 2 8, same number. So that we can arrange in 10 different way. By 1 and 2 shuffling, rearranging, we will get 10 different way. Then finally here all 4 2s. Here 3 2s, here 4 2s. Total is 8. 2 plus 2 4, 6 8. That only one way. So with 1 also one way. With 1 2 and 6 1s 7 ways. With 2 2s and 4 1s 15 ways, 3 2s and 2 1s 10 ways, 4 2s 1 way. Everywhere sum we are getting as 8. So total ways he can reach at the top, which means 1 plus 7 plus 10 plus 15 plus 1. That means 34 ways. Ninth question, what is the parity of the 20th term of the Varhanga sequence? 20th term. So consider the sequence here. Starting with 1, adding these 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5. These 2 adding, then the next one will get. These 2 adding, the next one will get. Like that it is going on. So which means odd, even, odd. Again odd, even, odd. So repeats every 3 terms. So the 20th term of the sequence, that will be even. So first is odd, then even, odd. So 20 is coming just before. 21st is the multiple of 3. So before that, that will be even. Question number 10. Identify the statements that are true. First one, the expression 4m minus 1 always gives odd numbers. That is true. 4m minus 1. 4m is an even number. That minus 1 or plus 1 always give odd numbers. So we can write true. Example, m you can put any number, any digit. So if m is equal to 3, 4 into m 12. 4m will be an even number. That minus 1 or plus 1, that will be odd. So for 12 minus 1, 11, that is odd. So that statement is true. Then second one, all even numbers can be expressed as 6j minus 4, which is false. We can put the numbers here. If j is equal to 1, for 6 into 1, 6 minus 4, 2. When j is equal to 2, 6 into 2, 12 minus 4, 8. J is equal to 3, 6 into 3, 18 minus 4, 14. These are the numbers what we are getting. Here all even numbers are not coming. After 2, 4 is not there. 6 is not there. Then 8. After 8, 10, 12 are not there. Then 14. It is going on like that way, which means all even numbers are not coming by this expression. So we can write these all are even. These all are even numbers, but not all even numbers. 4, 6, 10, 12, etc. are not in this result. That means not in by the expression. It's not getting by this expression, which means the given statement is false. Here the statement is saying all even numbers. We are not getting all even numbers. So that statement is false. Next, see both expressions 2p plus 1 and 2q minus 1 describe all odd numbers. You have to check each one. 2p plus 1. Put the values for p here. When p is equal to 1. 2p plus 1 means 2 into 1, 2, 2 plus 1, 3. When 2p is equal to 2, 2 into 2, 4, 4 plus 1, 5. So 3, 5, 7, etc. Here 1 is missing. So we can write odd numbers we are getting, but except 1. 1 is missing. The second expression 2q minus 1. Put the values for q 1, 2, 3 etc. When q is equal to 1, 2 into 1, 2, 2 minus 1, 1. When q is equal to 2, 2 into 2, 4, 4 minus 1, 3. Q is equal to 3, 2 into 3, 6 minus 1, 5. So, all odd numbers we are getting here. All odd numbers. So, 2q minus 1 describes all the odd numbers. But 2p plus 1, this one, does not describe 1. Therefore, we can write the given statement is false because the first one 2p plus 1 is not, when we are putting the values for p, we are not getting 1. So, the given statement is false. You can write here that as false. Now, next statement, the expression 2f plus 3 gives both even and odd numbers. 2f always, we know that 2 into f always it's an even number. That plus 3, that will be an odd number. Not gives both even and odd numbers. So we can check that through examples here. 2f plus 3, if f is equal to 1, 2 into 1 plus 3, 5. If f is equal to 2, one is odd number, the other one is even number. So if is equal to 2, 2 into 2, 4, 4 plus 3, 7. That also odd number, which means 2f is always even, that plus an odd number, that will be always odd. So here 2f is always even, but adding 3 makes that odd. So 2f plus 3 is always odd. So the given statement is false. Here the statement is both even and odd. That statement is false. We will get only odd numbers. Question number 11. ut plus ta is equal to TAT. Here we can see t is in the 100th place, which means t is equal to 1. And here this t also it will come 1. Then 1 plus a is equal to t. 1 plus a is equal to again 1, which means this a is supposed to be here 0. So 1 plus 0, 1. Then here u, here we supposed to get a is 0, which means this is 0. 10 supposed to get, and t is 1. So this will be 9. So 9 plus 1 is equal to 10. Like the way we have to think and do that type of questions. Here, first we have to see here, t plus dash is equal to again the same number. And also in hundreds place t. Hundreds place t means 1. Hundredth place t, which means t is equal to 1. So we can put everywhere 1. Now 1 plus dash is equal to 1, a is equal to 0. Here also 0. Then only u is remaining. That dash plus 1 is equal to 10, 9. So we can put u is equal to 9. So the number is 91 plus 10 is equal to 101. Here u is equal to 9, t is equal to 1 and a is equal to 0.